Hello, everyone. Hello, Pascal. Okay, so we are 5 minutes below, so let's start the meeting. So yes, this is a usual IETF meeting, so the not well and the best practices apply. So I expect by now you're all very aware of those best practices. There is the code of conduct. If you feel there are some misbehavior, please contact the Ombuds team. And then there is the patent rules. If you're aware of any IPR, new IPR, undisclosed IPR that's being discussed, please refrain from discussing it or please announce this IPR. And with this, so our agenda for today has two main items. The first one is SCHC header compression over IETF 20231017-1400. It's going to be Carles presenting. There is a new version of his draft. And then we'll continue our discussion on the architecture, and Laura has some slides. So yes, a lot of new work has been published. So at Interia, there is a new version of the protocol numbers for SCHC. And that's where we probably have to update to ask for a next header as opposed to protocol type. Other than that, the draft is pretty good, pretty stable. That's also where we are asking for an ether type for SCHC. Then there is the SCHC architecture version 1, which is out and covers what we discussed last time. The state of the discussion, it's not final, it's just where we were, just to write it down. And then there is the flow compression by Anna. And there should also be 54, I don't know why it doesn't show, but Carles has published, maybe it's at 6 low. The HC, SCHC HC for IETF-SCHC-20231017-1400. We have requested a session for IETF 118, and so we got it. It's going to be 90 minutes, and it's going to be at 5 p.m. So the last session in Prague on Thursday. We have asked for a big room, and the new thing we've done this time is we talked with Carles, and we agreed to make the SCHC meeting adjacent to the 6 low meeting. And that means that if somebody just comes for one day, he should be able to attend both meetings. And with this, Carles, if you want to take the ball and start sharing, or I can share for you and then pass you the ball. It's as you prefer.
Okay, maybe if you can share the slides.
I can see you. I can barely hear you, Carles. Maybe I can push the volume a little bit on my side. I don't know for the others. So I push the volume.
Can you hear me?
I can. It's just slow, so I don't know what others are getting. For me, I have to push the volume very high to hear you.
So, Ivan, is it okay? Yeah.
Well, it works. Pushing the volume, it works.
Okay. Okay, I'll try to also speak.
Slides, or you want to do it yourself, Carles?
Can you maybe browse the slides for me, please?
Yes, sure. Now, I can pass you the ball on them if you want.
Okay, well, as you wish.
Okay, you should have control now.
Yeah, I have control. Okay, thank you. Okay, hello, everyone. So the idea, the motivation for this presentation today is that for a while we haven't discussed this document in a SCHC working group or LP1 working group meeting. So this is intended as an overview rather than just focusing on the most recent updates. And well, some of you are also participants in the 6 low working group, but anyway, hopefully this will be useful. So anyway, yeah, what we are presenting is already contained in 03, which is a document version that was uploaded recently a couple of weeks ago. So in this document, what we want to enable is shown basically in the protocol stack on the right in this slide. So on the left, you can see the traditional 6LoWPAN based protocol stack over 15.4. But what we intend to do as the main goal in the document is to allow the use of SCHC header compression instead of 6LoWPAN header compression, or as an alternative. For example, to be able to compress IPv6, UDP, CoAP headers in this case. You may note how the idea would be to continue using 6LoW or 6LoWPAN fragmentation. So in addition, in the document, we also describe other options, other protocol stacks that we call transition protocol stacks, where 6LoWPAN header compression would still be used to compress IPv6 headers. And then, for example, RFC 8824 also enables compressing COAP headers by means of SCHC. So the two approaches in the slide are possible thanks to this RFC. And there is also another option, which is compressing, well, using SCHC to compress UDP COAP, which so far was only considered or enabled somehow by the present document, this 6-law draft. But now with the recent updates in the SCHC architecture draft, well, it's also covering mostly at least this part is covered in the SCHC architecture draft. So perhaps let's see how things evolve, but we might end up just from this document referencing the SCHC architecture document. So we'll need to see, to keep coordinating and align both documents. So then, because 15.4 networks offer or support different topologies like the star topology and then the mesh peer-to-peer topology, we define how it is possible to transmit IPv6 packets with headers compressed by using SCHC in different scenarios. And there's single hop communication, for example, and also there's multi-hop communication. So for the first one, single hop, the idea is that what you can see on the slide is the frame format that would be carried as the 15.4 frame payload, which would start with first field, the leftmost one on the slide, which is the SCHC dispatch, which would be a 6LoWPAN dispatch type that we plan to request for SCHC, actually in pages 0 and 1. And this is 1 byte intended to signal that what comes next is a SCHC packet, a packet with the header compressed by using SCHC. And in this case, in single hop communication, we state that both endpoints must store the rules for compression and decompression for their communication. And then for multi-hop communication, the document presently enables route over and mesh under. And for route over, there are 3 possible approaches. I see Laurent in the queue.
Yes, just a clarification on the previous slide. Yes, you put SCHC header, and I think that now it can be confusing. It's more the protocol header or something like this to avoid confusion.
Yeah, good point. Yeah, so this figure came from before the new concept of the SCHC header. So yeah, indeed, that's a very good catch. Thanks, Laurent. Okay, yeah. So
call it a SCHC header for this protocol or something, because as we go, we see that we have common needs for SCHC headers, like maybe we need checksum, or we need a next a session, or a next header or something, next protocol. So we have defined information, but we realize that depending on where we play, we might have a different format, like for IP, for Ethernet, etc. So you might need to define your SCHC protocol-specific header. It's still a SCHC header, but it's the thing we've defined, Laurent, is very abstract. It's not. We have a formal format, if you like, for V6, or at least we have a proposal for that. For the other formats, we don't really have a proposal. There is something in the PPP draft as well. But generically speaking, they're all SCHC headers. It's just that the SCHC header depends on where you place it. So it's a family. It's not. Yes, Laurent?
Yes, no, Pascal, I don't want to enter the long debate here, but just here, I think we have protocol header, and what we are now defining as a SCHC header will be in the SCHC packet that is represented above.
The SCHC packet that is represented above. Well, we'll have to come back to that slide. That we are not. I'm not 100% sure we are clear on the format. But after the SCHC dispatch just says it's going to be SCHC, then there needs to be some rules and some stuff where you write SCHC headers, which will be compressed. but we will know where there will be a well-known decompression scheme. And then that will tell you what's next. And that will be based on local rules. But the beginning will have to be based on well-known, because we have no way to signal which rules would decode the beginning of the SCHC packet. Anyway, so maybe we talk about that at the architecture. But basically, you're also a victim of the architecture here, Carles.
Yeah.
We'll have to define how it works in a very generic fashion, and then, oh, if it's PPP, if it's 15.4, if it's IPv6, if it's Ethernet, here is what you find.
Yeah. Okay, yeah, thank you. Okay, so about the multi-hop communication, there are the approaches of mesh under and route over. And for route over, we have 3 different methods. Now we have attempted also to define some acronyms. The 3 ones are the straightforward route over, SRO, the tunnel ripple-based route over, TRO, and the pointer-based route over, PRO. So next, we're going to see a few details about these 3 alternatives. So about the straightforward one, the idea here is a quite simple use of transmission of SCHC compressed packets. The idea would be that all routers must store all the rules in use for compression and decompression in the network. And perhaps a host must only store the rules for its communication with other endpoints. So we have some example network here showing which would be the rules that would need to be stored by the different nodes. By the way, host E would be an external node outside of the 15.4 network. Pascal?
Yes, we have this concept in the architecture of nesting SCHC compressions. Like you could compress from Ethernet all the way to IP, then have a new quote-unquote SCHC header to compress IP all the way to co-op, I don't know, and then have a new SCHC header. So you have nested sessions or nested instances. I think we use term session. But anyway, we have to agree on terminology, but we can nest them, and the endpoints are not necessarily the same. What I'm getting at is when you say all the rules, if we do a good nesting of SCHC compression, the router would just need to be able to decompress all the way to IP. But even if the above IP is compressed, it can still route. You see, so it would be kind of weird to have a single set of rules which compresses everything from IP all the way to the payload. You probably want to have SCHC rules which compress IP and then nested SCHC rules which compress the application. In which case, the routers would not need to know all the rules, as you say, but enough to decompress IP.
I see.
Yes, and so yes, Pascal, agree on this one, and maybe here the point is that maybe there is one SCHC rule that compresses like IP and above, and in order for the router to do its work, it needs to know that SCHC rule, so it can compress the IP part. You know what I mean? I mean, it's not necessary. So it's not necessary for the route there to be like 2 SCHC headers. If we are saying there is a router, the router needs the IP part so that it can do its work. So I just don't want for us to get in this impression that there should be 2 SCHC headers because there is a router somewhere. You know, we can still have like something that's compressing the IP part plus above, and yeah, well, I mean that would mean that there is SCHC on both sides, and the router decompresses the IP part, does the routing, and then, you know, maybe recompresses it again with the same rule, or sends it on the other way.
I'm not sure what you're saying, Alex. Actually speaking, this is a concept which you understand only for a part, because the rule must match the whole thing or much not. But then again, it's an architecture discussion, so I guess we don't want to steal Carles' time. But whether you do nesting rules, like this rule compress all the way to here, and then you have another set of SCHC rules which start here, or whether you want to have a single big rule that compresses everything. It's an architecture discussion. I have a sense that we don't agree on the result of this. So let's take it to the next discussion.
Okay. Thanks a lot for the comments. Then, okay, assuming the same approach followed for this example. Yeah, well, some additional detail is that the frame format used in the straightforward approach for route over would be the same as the one used for single hop communication, which is the main advantage here because of the low overhead of just 1 byte for the SCHC dispatch. And then the second approach is what we call the tunnel ripple-based route over. So the problem with the previous one, with the straightforward approach, as you have seen, is that the routers will have to store a lot of rules, or at least will have to store rules for the communication of all the endpoints involved. And here the idea would be to make all this a bit more scalable with network size. So one option is this approach, where the idea is we can have a tunnel, say from host A up to the 6LBR, which would be a route. By the way, the assumption is that ripple non-storing mode would be used. And then from there could be a downward tunnel, say to host B if needed. And then by doing this, the intermediate nodes, the 6LRs here, would be relieved from having to store all those rules for header compression and decompression. So then the penalty somehow is that, well, these are the formats that would be used to carry the SCHC compressed packets. So here we need to include all the routing artifacts, which would be compressed by means of RFC 8138. But, well, here the head overhead is greater than in the straightforward approach. So we have a sort of a trade-off here. By the way, you can see there are the downward format, then the downward one when the source is the root, which is a special case, which is a bit shorter. And then there's also the upward format, which does not include a source routing header. And the third approach for route over is the pointer-based route over approach, where the idea here is that, well, maybe moving to the format used in this case, it is that the SCHC compressed packet would be preceded by a SCHC pointer, which indicates where in the SCHC header is the location and then which is the size of the destination address residue, so that a node that receives this SCHC compressed packet, like say a router intermediate node, doesn't need to store the rule that has been used to compress the IPv6 header. And then it's possible for this node to anyway understand which is the destination address and then do the routing and so on without the need to store the rules. So this is a second approach which tries to be more scalable in terms of network size. So the intermediate nodes like the 6LRs, as you can see in the figure, would also not need to store any rules for this example. And then yeah, you can see that the format is just a couple of bytes for the SCHC pointer. Then this would need to be preceded by a SCHC pointer dispatch. So this is a second bit pattern that we plan to request to IANA to indicate that what comes next is the SCHC pointer. So then there's, in the draft, there's an analysis in Appendix B, which tries to study which are the pros and cons of the three different approaches. So for the straightforward one, the idea is that it's of low header overhead, just 1 byte, but then it's not scalable in terms of network size, rather suitable for small static networks. Then TRO has a greater header overhead, but then it's more scalable with network size. And some features are that it requires ripple non-storing mode And for intra-network communication, it requires traversing the root node, which might not always be optimal. And then PRO has a relatively low header overhead, at least for some cases. So it's 3 bytes plus some variable part. This variable part could be very small in only very special cases. For example, if the full destination address is known beforehand. But then in intra-network communication, when the prefix is known, then maybe it could be the additional part, the residue for the address compression would be something between 2 and 8 bytes, depending on how this is handled. And in cases where there might be, for example, communication between some node in the 15.4 network and then maybe some different possible external networks with different destination prefixes, then perhaps the whole destination address would be not compressed. So then we have this overhead, which is variable. And also this approach is also scalable with network size, like the second one. And as other features, well, the pointer-based route over doesn't require the use of Ripple. And for intra-network communication, in this case, it's not constrained to traversing a root node, although there might be other constraints from the routing protocol to be used, if not Ripple. And well, this is trying to summarize a little bit. So for small networks, perhaps the straightforward approach could be suitable. For larger networks, maybe TRO would be the best when communication with potentially several external networks is dominant. And PRO could be more suitable when intra-network communication is dominant. And well, so other than that, well, there are some next steps. So of course, possibly the main point is we need to ensure alignment with the SCHC architecture draft with new updates regarding the SCHC header, nested sessions, and so on. Other than that, also we plan to provide additional details on managing rule IDs. For example, when a rule ID needs to be unique within the whole SCHC over 15.4 network or not. And also we have some examples in Appendix A. So we need to complete also this section at least. Okay, so well, this is again intended as an overview of what we have so far in this document. Thanks for the comments already. And I don't know if there's maybe time or if there's other comments. Yeah, Laurent?
Yes, it's good because Pro has no counts, so that's a good name for the protocol. No, just to come back for the unicity of rules, and maybe it's something we have to discuss in the architecture working group. But when you put rule 1 for A, B, and C, this rule 1 could be different. And so in the border router, you should have a rule 1 for A, rule 1 for B, and rule 1 for C. In my view, you cannot share rules. It's really a point-to-point association between 2 points.
You mean in which of the 3 approaches?
For example, I don't see in this because here in LBR you have only rule 3.
So for example, say here?
Yes, in this one. So for me, you should have rule 1 for A, rule 1 for B, and rule 2 for A and rule 2 for C. So you have to associate this to the source with the rule ID. But that's my view. We think it's things that has to be discussed in the architecture group.
Okay. Okay, any other comments?
Thank you so much for your presentation. So I want to go ahead and see flow, and I guess we got our sessions back to back as we requested, right? I've not checked actually if we did, but
Actually, we didn't get the sessions back to back. And in fact, we requested, in Siglo, we requested a 90-minute session, but we got a 2-hour session on Friday. So, yeah.
Okay, we're on Thursday. Yeah.
Yeah.
So sorry. I mean, there won't be a way, but we tried. Okay, at least we tried.
We tried.
So
Yeah.
I don't know. I thought it was okay, but I didn't check. Okay, so yes, so I encourage people to go and attend Siglo as well. I realized that your biggest problems are related to the fact that the architecture is not so clear right now on how you do, in particular, SCHC nesting or no SCHC nesting, and what is the SCHC header and what we call a SCHC header, etc. And what the instances or sessions are. And so we need to be very crisp on all those in the architecture to allow you to progress, actually. So thank you so much, Carlos.
Thank you, Carlos. It's really, really
Thank you.
interesting. So, yes.
Laurent, with this, do you want to go and present your slide? Oh no, you have a little bit, 1 or 2 slides to present on the architecture, and then we'll go to yours. Okay, so let's go back. So on the architecture, I just wanted to give an update. So we provided a new version of the SCHC architecture, and the changes are limited. The main thing is we proposed the packet formats that were discussed in the previous meetings since IETF 117. The references are updated. In particular, Carlos, there is a reference on your draft. There's also a reference on the PPP draft and the protocol numbers draft. And we also have references on the LP1 RFCs, which are Sigfox and Laurent. So this is what's new. And then after that, the discussions is still very open. So I will go to Laurent's proposal. And Laurent, if you want to present it.
Okay, so let me find the slide. If I
You can upload if you like. I'm on it, so I can share and give it.
okay, you have it here. Okay, so yes, I'm not part of the architecture, and I don't want to be part, but that's some thought I got reading your document, and also what we have done on the SCHC header. So I tried to, as an exercise, to see how we can put co-op underscore regarding this architecture with. So if you can go to the next slide. I have control. Sorry. So I just took some hypothesis on SCHC header. So it says that it's carries some information like the next hop. We have also the session ID. So as we had a comment from Manoj last time, I will prefer not to call it seed because it's confusing. So I took session and also the CRC because maybe we need it, and we have already a discussion on that last time. So we have for the SCHC header, we have a rule ID space that is independent, and if we have only a single root, it means that we don't need a rule ID for the SCHC header. So as I say, I try to look at layer SCHC. It means what we have defined, as Carlos said, in 8824 and also in 8724. So we have 3 instances of SCHC, one for OSCORE that compress the inner message, one for co-op that compress the outer co-op message, and it's end-to-end between the device and the application. And then we have the network that can compress IP UDP here on the LP1 segment. And so we have also 3 independent rule ID space for these 3 instance. I don't know how we call it. So here it's a representation of this with some attempt to make things clearer. So maybe it could be also useful in what Carles shown, it's that when I put the name of the protocol, it will say no compress, and when I put it between parentheses, it means that it's compressed, so it's a regular SHIP packet with rule ID, residue, and payload. So, and then when I put it in bracket, square bracket, it means that here is encrypted. And when you have a white, so an empty line, it means that what is above has been installed, is viewed as a payload of CoAP. So same thing for CoAP. We have end-to-end compression of CoAP. And here it's what is not so obvious, is that then we have to put this on IP UDP. And here the destination port of UDP will be CoAP, will be SCHC, sorry, to tell that we are sending a SCHC message. Then so this either IP with the destination port equal to SCHC is compressed using rule to be sent on the LP1 network, and then it arrives to the core. The core takes the compressed IP, generate an IP message containing also a SCHC message. And on the other hand, you do the opposite things. So what is important is that here at the IP level, when we do the compression, we also add a SCHC header. So in this example, I took two values, one that says that it's the real port number, so it's 83, sorry, not 84, for CoAP, and then we have 8-bit that could be the SCHC CRC. So this gives you an example of what is sent. And if we represent it as the architecture, so we have what I call the session management that contains the rule ID for the SCHC header. And so we have a set of rules that has been associated to that. And to go to this session management, we need to look at the source address, and the source address, because we can receive packets from different elements, and it may go to a different SCHC session management. Then it arrives to the SCHC session management. Maybe in the rule header, in the SCHC header, we have some session ID, and so the session ID we point to a different SCHC instance, and in each SCHC instance, we have a set of rules for compression, decompression, and fragmentation. So that's an element. So last thing, and that's what interests me, is about management. So how we can make a way to modify the set of rules that we have in the SCHC instance and in the SCHC session management. So there is maybe one solution, but I don't like it. That will be to notify in the SCHC header that we have management on a SCHC management message or a regular SCHC message. But if we do that, it means that we lose 1 bit all the time to say if it's management or not. So maybe it is more general to do it in a rule. So right now we have 3 nature of the rule, which is compression, fragmentation, no compression, and we can add a fourth nature, what could be management. This management, we can say that it's only using link local addresses. So maybe we can imagine some anycast link local addresses, one for the device, and the other one for the application or the core, and so regarding the direction. And then we define some SCHC compression rules that are specific for the management, for instance, to do the key management, key establishment for OSCORE or DTLS. And we have also the rules to manage core conf for the device. So we need these rules, but we don't need to impose a rule ID. And during the implementation of the rule, we can say to give the rule ID to these rules. And of course, this rule ID is competing in the compression fragmentation no compression space. So that's, I sent a mail with that yesterday. So I hope it will be useful for future discussions.
Okay, many thanks, Laurent. I've seen the email effectively, and I recognize the texture and what you present actually helps understand that email because it looked a bit cryptic to me. But yes, that's, you have to look at that. I was still concerned by the need of this bit for saying it's management, but I don't know what else to do. So yes, we'll discuss that. Before we move on, yes, it would be nice to have a whiteboard discussion in Prague. The sad thing is I will not be in Prague. So there will be Alex, but that won't be me. That's what I understand. So if you do this whiteboard discussion, I can start a WebEx or something like that to join. So that's one thing. The other thing I wanted to share with you was Eric has sent also an email that Laurent, you have started to respond. And I hope that we would have a little bit of time in this call to discuss the mail by Eric. So if you're done and if there are no questions on what you presented, then maybe we can bring up that email. So I have it with me somewhere. So there is a long email by Anna, and I'm sorry, I'm still on it. I'm still showing it. But there is also, I'm looking for it, the email by Eric and answered by Laurent. Sorry, I'm digging for it. I thought I had it in front of me. Yes, it's called Some Commerce. Maybe I could share it, or I could read it. So Eric, do you mind if we go to your email and we discuss it a little bit?
Of course not. Please go. That was the goal, right?
Okay, good. Thank you, Eric, and thank you for those comments, actually. So you were saying, I wonder why the SCHC over Ethernet is always for IPv6. Actually, it was not the intention, because the idea was in the SCHC header version for Ethernet, the next header would be another Ether type. So it's basically saying, it's basically you're inserting a SCHC header in Ethernet just like you're inserting it in V6. Meaning that you have a next header which is of the same type as the next header that points on you. So if the ether type says SCHC, then the SCHC header must have an ether type which says what is the ether type of what's being compressed.
Okay, so basically you can, if you say next header, I mean, next ether type in this case is 800, this will mean IPv4, right?
Yes, exactly. You could mean IPv4, you could mean some other protocols which are not IP. I mean, we are at Ethernet level. So the idea was, it's always the same structure, if you like, something which says what's next, etc. But what's next is at the same level as you are. So that was the intention here. And I think that's what I have in the document, and I'm concerned that there was a concern there. I'll check, but that was the
alternatively, right? So there will be not so many things. So you can get one specific ether type for SCHC followed by IPv6, another one for SCHC followed by IPv4, for instance. As long as you don't go for too many, you are gaining 2 bytes, right? If not mistaken.
Yes, that's true. On the other hand, why restrict SCHC to only IP? I mean, we risk if we do that and we don't say in the SCHC header what is the ether type of what's next, then we are restricted to the ether types that we will define.
Now, Pascal, I think the confusion comes from the name NH, which is next header, and next header comes from the IPv6 vocabulary.
Yes, but in the SCHC over Ethernet document, in the 6.1 section of the architecture, it shows that you have, I could share it, I guess.
But I think, Laurent, this is maybe the source of my confusion there. If it's
It doesn't
called
say
next
next
ether
header,
type,
it says
then it's
ether type.
problem solved, right? Yeah. But let's not call it like Laurent suggested, next header, because there's a next ether type.
It is next ether type. That's what it's called in the figure. It's not called next header.
Okay, my bad. No problem. Sorry.
So yeah, it says in the 802 header, the ether type says SCHC, and in the SCHC header, there is an ether type that says IPv6 in that example, and then you have IPv6 header and IPv6 and HRP. I guess that's because the example I'm taking is IPv6 that you were misled, but it's really an example. Like the ether type could say it's v4, in which case you would have a v4 header, etc. So, well, that was the intention. I mean, if after saying that it's not clear, we can always rewrite a little bit to make sure it's more clear. Because each time there is a confusion, it also means that it could be written better. Then you say, understand, appreciate that an extension header is layer 3, while a protocol header could be, yes, exactly. You have this sentence where you say, an extension header is layer 3, while a protocol header would look like a layer 4 header. And it's
Correct.
weird to change a layer 4 header to a layer 4 header. That was exactly what I was trying to say last time. So I understand that from an architecture layering point of view, we agree that SCHC uncompressed version, which never goes on the wire, it should be a SCHC header followed by the UDP protocol if UDP is being compressed, right? We seem to agree on that. And then there is your but uppercase. But at least we have an agreement that the nice architecture is this.
Yeah, fully agree on this one.
Normally, an extension header has a length which is a multiple of 8. And yes, that's still true in our slide, Eric, because before compression, that's what it is. Let me go back. We have a problem with my browser. Now it's gone. If you cannot. Can you still hear me?
Yes.
I lost the window where you are, so that's a bit dreadful. The window is gone. I don't know on which screen it is now. But at least I did close the communication. Very incredible. What did I PC do? Okay, there you go. So let me bring up the slides of the architecture that show what I wanted to say. So at some point, you've got in red the SCHC header, which says next header equal URP. And that SCHC header is before compression, exactly like you say. You see, you have your 8 bytes, and then you've got options, which must also apply to the alignment. But that's before we compress it. And once we compress it, then it becomes a non-aligned green thing. But the red thing, at some point, on paper, in memory, if you like, was 8 bytes aligned.
Yeah, but then the green one needs to be 8 bytes aligned if it's an extension header.
Well, it is before compression, but once you compress a packet, what goes on the wire is what goes on the wire. I mean,
Yeah,
it's
if
after
you have, for
compression.
instance, if any middle box wants to pass the extension header chain, and SCHC is defined as an extension header, it needs to be able to pass it, right, to get what's after. And then you need to be 8 bytes aligned.
You mean if there is a
Yeah, it needs to be TLD,
well, yes,
right?
I mean, I agree that you're talking about middle boxes now, and that's this format is for the case where we don't have middle boxes, which would do that sort of games. Because when we do have a middle box, we have to resort to encapsulating the SCHC thing.
No, you don't
UDP.
have to. I mean, Pascal, you have extension headers can travel the Ethernet, in the internet. Not all of them, but many of them can do. UDP is safer for sure to traverse the global public internet, but there are different steps between a complete LP1 network or controls thing and the global internet, right? So there are, you can, for instance, go over a specific orange network.
Okay, so what you're saying is we could compress the black and purple things like SCHC PDU2, but you would not compress SCHC PDU1 because you want it to be aligned and pass those middle boxes.
And to be correct, if it's an extension header, now if it's a protocol header, that's different, right? It's an extension header, it must be 8 bytes. You will, maybe it will go over the internet, but it will, and then for this one, I'm reading back my AD8. I'm afraid it will not pass the ISG. If you're on the white, you are not aligned on 8 bytes. And then I'm removing my AD8 now, right? So.
Oh, okay. Yeah, so one way of answering you is to say, hey, okay, then we send the red uncompressed, which is aligned to 8 bytes, and then we compress PDU2. If we do that, though, it will say next header equal ULP, meaning whatever that ULP is. But in practice, because of the SCHC header, we'll have to understand that the ULP is compressed. And
Yeah, but
so if there is a middle box which looks at the ULP header, it will not find it.
What you can do is something similar to ESP and obfuscate the next header. So it will never be designing a load, right? It will never be 6 for TCP. It will be blah, blah, because you obfuscated 6 by XORing by something else.
Okay. Okay, but and it passed for ESP, so you're saying if it passed once, it will pass again. Because yes, I mean the machine which will, if there is an intermediate machine, it will find that it's scrambled, and yes, it cannot pass it, but
yeah, it's pretty much like you are doing ESP in the chain, right? So you cannot pass the rest. What is compressed or encrypted is basically the same thing.
Yeah. It's just a compression is an encryption where you publish the rules. Yeah. Okay. So what you're saying is if we send the red in the air and we compress the PDU2 and we scramble the next header equal ULP, we're all set. Designing allowed, right?
Yeah. I mean, you can. And then if you want to be an extension address, and again, you're right, it's nicer, it's because you cannot get layer 2, layer 4, and layer 4, right? But as I said below in my email, right, that you have this IPCP, a very old one.
Yeah.
We can, of course, it's not the same compression, but it's basically the same place and the same features, the same function. Different ways of doing it, right? Less efficient, blah, blah.
Oh, well, please. And they have the draft of our PPP anyway, yeah?
Sorry?
So I have the draft for SCHC over PPP. We'll have to explain how that works. And so yes, you want me to read? You say IPCP is similar to SCHC, but uses a protocol header. What's the difference? That's your question?
Correct. I mean, this is a rhetorical question, right? So,
well, effectively, the SCHC header itself is an abstract data. And then we have a SCHC IPv6 header, which is the one that I just showed. And there is a SCHC PPP header. And when you can find the SCHC information somewhere else, then you don't have to write it in the SCHC header. And effectively for SCHC, with the IPCP, we have, what do we have actually?
there's the only one I found very easily. If you go by the protocol number, that's how I find it.
Yes, but because in PPP you have the session, so because you have the PPP session, we don't need the one in the header. You have the CRC in the end, so we may not want to do the checksum, but we might, because we will have an IP checksum later, or we might still want to have our checksum. And then we need the pair of application layer. I guess the IPCP didn't tell you, and it just tells you it's IPv4, IPv6. I'm trying to remember what else there is.
Yeah, I mean,
but it basically says it's IP.
I don't say, Pascal, I don't say reusing IPCP, but it's very similar in the sense of IPCP is not an extension header. It's more like a protocol number. And that's what I think it will be much
it's more like an ether type,
architecture point of view, but safer for process-wise. At this stage, right, I have no head, right? So I can be over.
No, the point is the IPCP. Well, you have the NCP and then the IP or the IPv6 CP, which the NCP tells you the layer 2 information, IPCP tells you it's IP, and here is, and so it's basically like an ether type or something. In my it's below IP, right? What I'm saying is, it tells you that what's next. It's like it tells you that what's next is IPv6 or IPv4. It's like an ether type of sort, right?
Mm-hmm. Yeah, I mean, again, it's pretty. There is no need. I don't intend to reuse IP comp byte by byte, but the concept of IPCP runs over everything, can be in between everything, right? Basically, can be above IPv4, IPv6, and can have IPv4, IPv6 after. So, whatever.
Yeah, I have to do some homework to understand better what you're saying here. But just how it's inserted, etc. I have to understand. And so your last sentence was using a new IP protocol would allow the use of SCHC over IPsec.
Yeah, because you can chain SCHC after AH, for instance, or after ESP.
We can already chain SCHC after AH anyway.
Not
because
really, right?
You can chain headers after IH, but not ESP, right? So your point is mostly for
extension
ESP?
headers must be, I mean, they've got a fixed place. Again, that's the issue, right? If you put extension header, it must be before or after. And most of them are before AH and ESP. So if you use an IP protocol number, you get AH. And you can change it to AH or ESP, obviously, right? Or the same thing over IPv4. So you can get IPv4 header, SCHC header, and then the payload of IPv4. Not that I like to support IPv4, right? But yeah.
Just one question, Laurent. Do you want to say something?
Yes, I want to, just if you come back to the previous slide, Pascal. And I think it's also a source for confusion. Here you put the next header in 8 by 8 bits. And if we are at layer 2, it will be 16 bits.
Oh, but this is the SCHC header for IPv6. I was saying it's an abstract format. The SCHC header is the abstract information, but each layer has a different format.
If you put the SCHC above layer 2, then you will have if a type for SCHC,
different layout.
Why?
Yeah, it's a different format because you have to place different types in there.
You need to define for each protocol you will want to compress a new SCHC header.
I guess so, yes, because what you put in it might be different. For instance, in PPP, I define one where I don't have a session, for instance, because the session is implicit
Yes.
because of the PPP session.
No, but when
So
you do compression at layer 2, you will know that you are layer 2, and so you know at this time that you are dealing with things on
yes, that's the point.
18 bits. So
You know where you are,
for me,
so you should know.
That's one drawback of having a byte representation of the SCHC header. I think it should remain abstract.
Yes, it is. This is the byte representation is just because at some point we needed to present it to IPv6 and ask for a next header, which is true or not true, depending on how resolved the questions by Eric. But yeah, that was only the version of the SCHC header 4. It's the SCHC next header, if you like. It's the SCHC. This I should not have called this picture or the drawing next SCHC header, because it was just a drawing in the case of IPv6 in a header chain. But yes, it's not the format for PPP, because in PPP I have another format. It's not the format for sorry, I had a ring.
Layer 2.
Not the format for layer 2 either. Yeah. Excuse me, I had. Sorry. Excuse me. So I'm sorry, I had a non-maskable interrupt, but it's masked now. So yes, what I was getting at is this format was just for V6. We need to be more clear on that. We need to define a format everywhere. And so that's many formats effectively on the when we want to spell the bits. And I understand that you're saying that everything which is only compressed, we should not even need to spell out the bits, right? That's where you're getting at? No?
For me, the rule is the format.
Yeah, exactly. I see what you're getting at. And it's for everything on the wire, I would agree with you. And the discussion was whether there is a time something which is not on the wire like this, or whether we just have the rules. And I think I had an argument for needing this format. I forgot which one it was. Because effectively, yes, if the rules tell you this exists and you have so much bits in the residue to find header length, then you have your header length, and it's never really in the air. It's never really written with a bitwise format anywhere. So you don't really need to have to know this bitwise format. So that's basically your argument, right, Laure? Why should we ever spell it? At least we need, I don't know. We need to be able to explain when we can compress next header, and when we can compress session ID, etc., etc. And if it's how it's obtained when it's compressed. But effectively, in the air, if the SCHC header, quote unquote, is always compressed, then there is never really a need for a bitwise, a drawing like this one. I understand your argument, and I'm just like, I thought I had a reason why I thought we needed it, but just now it doesn't come back to me.
CRC, but I think we can discuss about that. I think we can do the CRC on the compressed version.
Oh yes, it was the CRC. Good. Yes, just to explain to the others, at some point, there will be a CRC to be sent or a checksum for some content. And we need to know if the CRC is done on the compressed or on the uncompressed version. If it's done on the compressed version anyway, we're back to what you are saying, Laurent. We don't really need the format. And all we need is to be able to expand the values so we can have them and work with them, but they don't need to be with a bitwise format. Yes, if we do that before we push a CRC, I agree. Yeah. Then the checksum. For instance, in this picture, the checksum that we have is the one in the SCHC PDU. So it's the checksum of the compressed SCHC PDU2. So the real value of the checksum in the black piece is lost. And we just validate that we receive all the bits of the compressed version correctly. But then the other way of doing that could have been to say that the checksum in the compressed red block is the checksum that you have before you do any compression. So you take the first picture, everything uncompressed. You have a ULP header, which could be, say, UDP, which has a checksum, and you have the red piece, which also has a checksum, and which protects everything after it. And basically, if we said that the checksum of everything uncompressed is the one that goes in the compressed PDU, then we could have validated that when we uncompress, we get the exact same result. On the other hand, if we say that the checksum that goes in the green SCHC PDU1 is after compression, then we validate that after compression, we receive the packet correctly. But when we re-expand, we don't guarantee that we get the expansion that corresponds to what was there originally. That's the difference. Basically, whether the checksum in the SCHC header after compression is the checksum after compression or before compression. So the big difference being that we know that we restored exactly the same packet, or we don't know. If we compute the checksum of the compressed green pieces, then we know we transmit them well, but we don't know after restoration that we restored the original packet. That's the difference. From there, I don't know. I mean, how important is it that we know we restored the original packet? Could it be that some rules allow some slack in what's being restored, for instance, some padding, which could be restored to zeros or to something else, and it would not matter? But the checksum would change.
I think it's a super interesting discussion, but we are like 10 minutes after the hour.
Oh, we have.
Oh, probably.
Yeah,
Yes.
okay.
Let's stop here, and yes, we'll continue. Well, in Prague, I'll try to set up to reserve a meeting room and set up a video call for Pascal to be able to be present there. So
Okay.
yes. So thank you very much. Thank you, Pascal. Thank you, everyone, for being here. And yes, see you in 3 weeks' time, I think.
Yes, physically or not.
Yes,
Okay.
physically or not. See you.
Okay, bye-bye.
Alors, ça devient rigolo.